Hello, my name is Dominic Egger, and I'm actually an expert at AI platforms. And I wanted to talk a little bit about some of the future work that we're about to work on to make it easier for consumers, enterprises, as well as the world above to be able to actually use AI at the edge. We're embarking on an amazing journey where confidential computing power is shifting from centralized data centers and bringing it closer to the edge. And what that really means is the data that we generate at different sites, at different environments, can easily be used as part of a dynamic approach to help models learn about your business and how you operate. AI has, in essence, been the forefront of imagination for the last couple of years. But the really key innovations around that is companies like Apple, who in essence have designed chipsets that are really focused on the simple fact of enabling privacy by default. So when we think about Apple Silicon, we think about confidential computing, we think about AI at the edge. These technologies are really here to refine the way that we process, protect, and power the future of intelligent devices. Really, the ideal is simple. We're here to solve a very complex problem, and AI is the way to basically be able to do that. So, thinking about how AI workloads generally work and how they're compared to other solutions around the world when it comes to traditional machine learning that's supervised and unsupervised, time, energy, latency, as well as efficiency come into a big forefront of this, but also data privacy. Now, when we think about this, the ideal is when we're using a centralized cloud service, we're relying on the cloud provider and the service provider that has developed the models or technology to, in essence, say that we are going to protect your data and we're going to provide a mechanism that does that. But as we have known over the last couple of years, every type of breach that's happened regarding any type of PII that's being used in the marketplace today to train models, as well as even simple reporting, can easily be breached because nothing is being protected in memory. But the forefront of Apple Silicon, Apple Intelligence, as well as their ARM-based chipset, has really changed the game because we have a ecosystem we can develop in that is now truly secure, and it has an ability to provide a mechanism to say that this is truly being protected. And not only are we able to do that from a technology exercise and being able to try to exfiltrate it, but also we see in our day-to-day lives where we have the massive Apple ecosystem that now can basically connect to multiple devices securely. You can copy and paste over different devices, and you're in essence staying within a trusted execution environment that cannot easily be hacked. And Apple has proven that time and time again that they're not able to have anyone get in this ecosystem readily, easily, even law enforcement, without actually physically accessing the hardware and spending millions of dollars trying to get into it, and then eventually maybe getting a piece of it. Now, when we think about Apple Silicon, the iteration and how chipsets have been growing from the M1 to M2 to the new M3 chipsets is around power efficiency and ease of use. Now, when Apple decided to kind of move away from the Intel ecosystem, they needed a chipset that provided the performance, the security, and to be able to provide the best class hardware to be able to design and deploy on top of. Now, what's great about this is they have, in essence, built a privacy-based operating system that even if it actually is breached or if someone does have access to the hardware, it's still very impossible to be able to get that information. And then Apple decides to not only provide that mechanism, but they also give you some massive powers where you can now federate that information across multiple different parts of the hardware. So whether it be something very simple as maybe doing image analysis using the onboard GPU, or doing neural processing and being able to use those 16 cores that are available on demand without actually affecting the performance of the operating system, is really game changing. And the ideal around this is, we're living in a world where transactions happen in the trillions. It used to be billions, it used to be thousands, it used to be hundreds. We're getting in a situation where we need to be able to scale operations, be able to design an approach that allows you to have a cohesive environment, but then ultimately delivering on the right time and the right device set to be able to say that this data was secure when we analyzed it, this is secure while we view it, and it cannot easily be manipulated without massive intervention and expertise in that specific hardware. Now, the magic always lies within Apple's approach to privacy. The ideal with, Apple's pioneering using the Face ID and protecting healthcare biometrics, fingerprints, retina. The ideal really is being able to provide true isolation and computation that can actually happen in a secure and efficient manner. Historically, when we actually encrypted things in use through the application layer or at rest, performance definitely degraded over a good chunk of cycles. And the ideal around this is when you actually have to take risk in protecting your data, sometimes that actually is necessary. But thankfully, the Apple ecosystem provides this approach where it doesn't affect the performance, and you can get native protections within the system itself. But we're building this trust into AI, and the ideal around this is taking this concept of confidential computing, where companies like Intel, AMD, ARM themselves have developed this framework and ecosystem, but not actually gluing all the pieces together. And then that's the reason why I'm really bullish about the Apple ecosystem, the silicon that's being provided, and the fact that they do it best. They're providing like a simple interface, using Swift, being able to process the data in a secure enclaves on the fly, and ultimately, even if you have access to the physical hardware, it's almost impossible to be able to see what is actually truly being processed. And ultimately, why this is going to be important is the simple fact that customers are demanding privacy. Lawsuits are getting bigger, technology is getting more complex, and if you always have to redesign your footprint to support your application, just so you can meet actual requirements at the federal level, local level, or even global level, you don't want to have to keep re-architecting that. And that's the simple reason why the Apple Silicon is very important. Now, I see this being very powerful when it comes to banking sector, healthcare, even in crypto. And the ideal around this is when you provide a framework that just gives you everything you need out of the box. This really provides a great footprint so that you can easily rack 50 to 60 Mac Minis, have them clustered, have them process, aggregate the token creation for every one of the requests that are coming in, and to efficiently do it where any user doesn't ever have to know what's powering the back end. They just know that the data that's being sent to them is truly private. Now, the ideal around being able to do this stuff at the edge is really around reducing latency, saving bandwidth, being able to allow for real-time access, because if you have a globally distributed network, the ideal is you're waiting for things to happen. And sometimes, even a neural network, for example, needs to be able to aggregate, correspond details, being able to output things as customers requesting, and it has to wait for that data to be processed, and it has to build a model based on those specific data points. You're already gonna have a situation where it's more supervised machine learning than it actually truly is AI. But that's really kind of the concept that I'm looking at, because of the simple fact that when you're standardized on a system that you think is going to be great and performant, you want to have longevity at it, and you don't want to have too many design changes like with Intel and AMD has done over the previous years. Now, we see this time and time again with companies like Tesla, with Waymo. They're really relying on edge AI processing to be able to do image recognition, train on it, send the details back, and then to basically have a fleet of engines that allow you to basically drive better, safer, and hopefully more efficient when it comes to actually providing a fleet the ability to see what it looks like and how to optimize those specific decisions as it's making for you while you're sitting there in the driver's seat. Knowing that also that detail can be tampered with. So, I would hate to have to be in a car where you're truly, focusing on, hey, this is safe, it's been tested, but then all of a sudden someone gets in the system and, compromises it and also puts your life in jeopardy. So a lot of these things have to be really considered when you're thinking about the actual components and what makes AI safer. And that really comes to the point where, I'm really bullish about how Apple Silicon has really, transformed from, the basic, protecting keys to now actually full workloads. And technically, because of the commodity nature of Apple's ecosystem, enterprises can in essence buy racks of these things for a third of the cost and outperform a lot of the different type of computation activities they would normally have to do, where they have to purchase half a million dollars worth of GPUs, and then also have a staff, train them, infrastructure management, and ultimately always having to retool because that technology is always going to change. Now, when you have a framework that is tried and true and you build on top of it, that's really what it comes down to. We want to give you an ability to focus on what makes it important, which is actually getting relevant information out of your data, training that information on the fly, and not having to write a piece of code to be able to do that. So whether you're a developer, whether you're a business leader, a tech enthusiast, now is the real time to embrace the future of how edge computing can play into an integral fact. It's faster now, it's more secure, and it's here today. And in the next couple weeks, I'm going to be talking more specifics around that technology, and the reason why I actually made the decisions I made over the last couple weeks, so that you can kind of see where the iteration of where I started with confidential computing, in essence, is coming into this to a unified approach to AI, and that's really what's going to come down to the exciting point of how this technology is going to grow. I look forward to providing you guys more demos, being able to provide more information, and ultimately I'm really excited about building something from the ground up again, and being able to show the world that it doesn't take a lot of work. It just takes a lot of thought leadership to be able to truly see what customers want and how they can use this information. Thank you for watching this video. I'm not going to keep you guys in too much suspense, but this is a really exciting topic for me, and I really wanted to get out right away because it's something that we're going to be hitting the ground running on, and hopefully be able to show you some amazing stuff that's about to be launched. Thank you for your time.